In this unit, we will study the types of motion, scalar and vector quantities, the relation between displacement, speed, velocity, acceleration and equations of motion. The first thing concerning the motion of an object is its kinematics. Kinematics is the study of motion of an object without discussing the cause of motion. We see many different things around us. Some of them appear to be moving, while others seem to be not moving. If you look at this image, you'll see birds, butterfly, and clouds moving. However, you'll also see trees, grass, flowers, and a man resting in his garden. So, how do you precisely tell a moving object from a non-moving one? There are two states of motion in which an object can exist: motion or rest. Well, a body is said to be at rest if it does not change its position with respect to its surroundings. Where surroundings are considered as places in its neighborhood where various objects are present. Similarly, a body is said to be in motion if its position changes with time. Talking about the previous picture, we may find that the resting man was in the state of rest while the flying birds and butterfly were in the state of motion. If we observe carefully, we will find that everything in the universe is in motion. For example, the motion of a car in a straight road is different from the motion of the blades of a fan, which is again different from the way a pendulum of a clock moves. Talking about the types of motion, there are three types, namely translator motion, rotatory motion, and vibratory motion. There are many ways in which things move. Some objects move along a straight line, some move in a curved path, and some move in some other way. A car moving in a straight line, similarly, a person moving in a straight direction, and a bicycle taking a turn on the road are all the examples of the translatory motion because they are either moving in a straight line or in a curved path. It is further divided into linear motion, circular motion, and random motion. We come across many objects which are moving in a straight line. The motion of objects such as aeroplanes flying straight in air and objects falling vertically down are also the examples of linear motion. When an object is attached to a rope and swung in circles, it undergoes circular motion. Circular motion refers to the movement of an object along a circular path. In this type of motion, the object continuously changes its direction, but the distance from a fixed point remains constant. In case of Earth moving around the Sun, we can consider Earth as particle and motion as circular motion. Have you noticed the type of motion of insects and birds? Their movements are irregular. This type of disordered or irregular motion of an object is called random motion. Thus, motion of insects and birds is random motion. Study the motion of a fan. Have you ever wondered what makes it spin? The motion of a wheel about its axis, and similarly the motion of the Earth about its geographic axis that causes day and night, all these are examples of the rotatory motion because they are moving in a circular path about a fixed axis. So the spinning motion of a body about its axis is called its rotatory motion. Now consider a baby in a swing. As it is pushed, the swing moves back and forth about its mean position. The motion of the baby repeats from one extreme to the other extreme with the swing. The to and fro motion of the pendulum of a clock about its mean position, or how the children move as they play the seesaw game. What motion do they possess as they move the seesaw? Well, these are some of the examples of vibratory motion as they are moving about its mean position. To and fro motion of a body about its mean position is known as vibratory motion. In physics, we come across various quantities such as mass, length, volume, density, speed, and force. We divide them into scalars and vectors. A physical quantity which can be completely described by its magnitude is called a scalar, while a vector is described by magnitude along with its direction. It would be meaningless to describe vectors without direction. Some of scalars' quantities are mass, length, time, speed, volume, work and energy. Whereas if we take a look at some of the examples of vector quantities, they include velocity, displacement, force, momentum, and torque. Now it is very important to differentiate a vector from a scalar quantity, and to do so we generally use bold letters to represent vector quantities or a bar or arrow over their symbols such as F, A, D. Graphically, a vector can be represented by a line segment with an arrow head. In figure, the line AB with arrow head at B represents a vector V. The length of the line AB gives the magnitude of the vector V on a selected scale, while the direction of the line from A to B gives the direction of the vector V. When dealing with motion, we come across various terms such as the position of an object, the distance covered by it, its speed, and so on. Let us explain some of the terms used. The term position describes the location of a place or a point with respect to some reference point called origin. If you want to describe the position of a schoolboy from his school, let the school be represented by S and boy by B. The position of the school from the boy will be represented by a straight line BS in the direction from B to S. Let us take a look at this picture. A man goes to work by motorcycle as shown in the diagram. Let 200 m be the length of the curved path between man and factory. Then 200 m is the distance between these 2 points. Whereas the shortest distance of 120 m in the same direction is called displacement. It is a vector quantity and is represented by d. Length of a path between 2 points is called the distance between those points. However, displacement is the shortest distance between 2 points which has magnitude and direction. It is a vector quantity and is represented by d. Now the person going to work must be traveling with some speed. What information will we get by knowing the speed of this person? Speed of an object is the rate at which it is moving. In other words, the distance moved by an object in unit time is its speed. On the other hand, velocity tells us not only the speed of a body but also the direction along which the body is moving. Speed is measured by the distance covered by the object and time taken by it. Here s is the distance covered by the object, v is its speed and t is the time taken by it. In this equation v is the average speed of a body during time t. It is because the speed of the body may be changing during the time interval t. If the speed of a body does not vary and has the same value, then the body is said to possess uniform speed. Velocity of a body is a vector quantity. It is equal to the displacement of a body in unit time. Here d is the displacement of the body moving with velocity v in time t. In this equation, v is the average velocity of a body during time t. It is because the velocity of the body may be changing during the time interval t. However, in many cases the speed and direction of a body does not change. In such a case, the body possesses uniform velocity. That is, the velocity of a body during any interval of time has the same magnitude and direction. Thus a body has uniform velocity if it covers equal displacement in equal intervals of time, however short the interval may be. When does a body possess acceleration? In many cases the velocity of a body changes due to a change either in its magnitude or direction or both. Acceleration is defined as the rate of change of velocity of a body. Here delta v is the change in velocity, where vf is the final velocity and vi is the initial velocity. The average acceleration of a body given by equation is a during time t. Let the time t is divided into many smaller intervals of time. If the rate of change of velocity during all these intervals remains constant, then the acceleration also remains constant. Such a body is said to possess uniform acceleration. Acceleration of a body is positive if its velocity increases with time. The direction of this acceleration is the same in which the body is moving without change in its direction. Acceleration of a body is negative if velocity of the body decreases. As the car speeds up, the velocity of the car increases along with acceleration, while the acceleration decreases when the car slows down. Negative acceleration is called deceleration or retardation. A graph, like a picture, is worth 1,000 words. Graphs not only contain numerical information, they also reveal relationships between physical quantities. The quantities between which a graph is plotted are called the variables. One of the quantities is called the independent quantity and the other quantity is called dependent quantity. This section uses graphs of distance and velocity versus time to illustrate one-dimensional kinematics. A distance time graph is a graphical representation of how far a body has traveled in a specified amount of time. It is used to depict the relationship between distance and time, where distance is plotted on the y-axis and time is plotted on the x-axis. When a body is steady or stationary, when a body is moving at a uniform speed, when a body is moving non-uniformly with increasing speed, and when a body is moving non-uniformly with decreasing speed. In the graph shown, the distance moved by the object with time is 0. That is, the object is at rest. Thus a horizontal line parallel to time axis on a distance-time graph shows that speed of the object is 0. The speed of an object is said to be constant if it covers equal distances in equal intervals of time. The distance-time graph as shown is a straight line. Its slope gives the speed of the object. The curved line in the distance versus time graph is clearly moving upwards in the first figure. This indicates an increase in speed, which is also known as acceleration. In the meantime, the curve in the second image bends downward. This indicates that the body's speed is slowing. In layman's terms, this downgrade denotes the object's deceleration. Here we will learn about a speed-time graphs where time is taken along x-axis and speed is taken along y-axis. It shows the motion of an object against time and is also referred to as velocity-time graphs. When the speed is constant, the speed-time graph, with y-axis denoting speed and the x-axis denoting time, will be like this. As clear from the graph, the speed is constant, c, throughout the time interval. No matter how much the time changes, the speed will be c at every instant. When the acceleration is constant, and the initial speed of the particle is 0, the speed of the particle will increase linearly. As shown in the figure, the speed of the particle will increase linearly with respect to time. The slope of the graph will give the magnitude of acceleration. When the acceleration increases with time, the speed-time graph will be a curve. Note that since the acceleration is continuously increasing with time, the magnitude of the slope will also continuously increase with time. The curve in this graph bends downward. This indicates that the body's speed is slowing. In layman's terms, this downgrade denotes the object's deceleration. As we know, motion is the phenomenon in which an object changes its position. Equations of motion was given by Sir Isaac Newton. He was the first to give the fundamental physical laws that deal with objects and their motion. Equations of motion are mathematical equations that explain how a physical system behaves over time. These equations relate initial velocity, final velocity, acceleration, time and distance covered by a moving body. The first equation of motion provides the relationship between the initial and final velocity, time, and acceleration, as follows. Similarly, the second equation of motion provides the relationship between displacement, time, acceleration, and initial velocity. And the third equation of motion provides the relationship between initial and final velocity, acceleration, and displacement. Free-falling object is an object that is falling under the sole influence of gravity. Any object that is being acted upon only by the force of gravity is said to be in a state of free fall. Free fall is a kind of motion that everybody can observe in daily life. We drop something accidentally or purposely and see its motion. At the beginning it has low speed and until the end it gains speed and before the crash it reaches its maximum speed. Well, the remarkable observation that all free-falling objects fall at the same rate was proposed by Galileo. He dropped various objects of different masses from the Leaning Tower of Pisa. He noticed that all the freely falling objects have the same acceleration independent of their masses. As you know, things fall because of the gravity. Thus, the falling objects gain speed while falling because of the gravitation. We call this acceleration in physics gravitational acceleration and denoted with g. The value of g is 9.8 ms squared. For bodies falling down freely g is positive and is negative for bodies moving up. Thank you for watching. Please like and subscribe to my channel and press the bell icon to get new video updates.